Hello once again, class. Today we're going to be taking a look at multiplying and dividing rational expressions. Rational expressions. You've been dealing with rational expressions from the last section, and now we're going to begin doing some manipulations with those, learning how to simplify multiplication problems or division problems using rational expressions. So I hope the last section was okay for you. Personally, I enjoyed it quite a bit. I thought the graphs were really cool. Seeing the graphs of some of those functions was pretty amazing, actually, to see how those equations graph out using the Desmos graphing calculator. So without delay, let's get on to some examples here and hopefully make this plain and easy for you. Okay, let's switch over here to our whiteboard. Here's our first example. We would like to take 3ab divided by 4c to the fourth times 16c squared over 9b. Now, the first thing you need to realize is that this is just an ordinary old multiplication problem. There's really no magic to this. Let's take the constants or the coefficients of these expressions and let's multiply them together. So let's take 3 and we'll multiply by 16. And then we'll take and put the AB and then the C squared. A, B, C squared, like that. We'll divide all of this by 4 times 9, B times C to the fourth. I'm just reordering a little bit. Remember, you can multiply in any order. No problem with that. And I hope now you can see that we can do some canceling. There's no need to take 3 times 16 and get 48. I mean, why do that? We can put 3 into 9, we can put 4 into 16. It's just easier. So you look at this, we can say 3 goes into itself 1 time, 3 goes into 9 3 times. 4 goes into itself 1 time, 4 goes into 16 4 times. So we're left with 4 in the numerator, 3 in the denominator. Pretty straightforward. So this is equal to 4. And now A has nothing to cancel with in the denominator, so we'll just have 4A. And then we have B's, and the B's, notice what happens to the B's. They're the same top and bottom, so they cancel out. And then we have C squared divided by C to the fourth. And C to the fourth, you remember the rule, you subtract the powers. If we do 2 minus 4, we get negative 2, but that means 1 over. Remember, we have c to the negative 2, that's 1 over c to the positive 2. So this just becomes 3 in the denominator now. 3, and the c squared here, this guy gets canceled, and this becomes a 2. Okay, so it's going to be c squared. I need to get back to my black color. C squared. Okay. 4a over 3c squared. That's your simplified result. Pretty straightforward, huh? It's not too hard. So that's your answer. So again, it's just straight old multiplication and division. I hope that this is familiar to you. Remember that it might be good just to review this. I could review this little rule here that you have, if you have a to the m divided by a to the n, it's equal to a to the m subtract n. You remember this? And another rule that's helpful to remember is that a to the minus m is equal to 1 over a to the positive m, like that. These are a couple of rules that will be helpful for you to remember. And I think you also can realize that if it's 1 over a to the negative m, then that's a to the positive m, and vice versa. Okay, let's see if we can pick up another example. Example number 2 coming up. Okay, example number 2, t squared over t plus 5 times t minus 5 multiplying t plus 5 over 6t. Now, I want you to remember that when you have something like this, a line like this is in fact a grouping symbol. It's kind of like you have parentheses around it, okay? So this t plus 5 is exactly the same as the t plus 5 below. So we can put it all as one fraction. Basically, all you have to do is just recognize that these two are multiplying. The t squared is multiplying t plus 5. So notice that this guy, sorry about that, this guy right here is multiplying the t plus 5. Okay? It's important to recognize that. And these are grouping symbols. So these two lines here mean that you have to deal with this guy like this, recognize that it's multiplying all of this here. So let me just rewrite it to make sure you're clear. I think you're probably already clear on this, but just in case, let's just rewrite this a little differently to be certain that it's making sense to you. So let's write it as follows. We'll write t squared times t plus 5 all over t plus 5 times t minus 5 times 6t, like that, okay? And now we can do some canceling. You can see that this is the same. They cancel. And this t squared, remember the rule? A to the m divided by a to the n is a to the m minus n. So what we have here in this situation is we've got t squared divided by 6t, okay? And the t's subtract. So this becomes, in the numerator, t to the 2 minus 1, because this is the first power right here, okay? That's the first power. Let me just emphasize, that's power 1. And this is power 2, okay? So you subtract them. 2 minus 1, okay? So, and then, of course, there's nothing else left in the numerator because we already canceled out the t plus 5. So what's in the denominator? In the denominator, we have 6 times t minus 5. Like that, which is equal to just simply t in the numerator. And in the denominator, we can leave it factored or we can multiply it. And I think we're just going to leave it factored. It'll be 6 times t minus 5. Okay, so there's example number 2, simplified. Okay, so we've multiplied these two expressions together, these two rational expressions, canceled out what we can cancel. We've subtracted the powers there, and we get this result. So hopefully that is something, I think this is almost review. We did some of this before, but this is perhaps a little bit more involved than what we did in the past. So now let's move to example number 3. So in example number 3, we are going to be dividing by b plus 5. So it's the expression on the left divided by b plus 5. What is b plus 5 over? Is it over something? Meaning, is it, could you write it as a fraction? And the answer is yes, you can. Why don't we just write it like this? Let's say that it's over 1, because it is. Anything's over 1. Any number or any expression is over itself, is over 1. So we can write it like this. Now, the importance of writing it like this is so that you can understand that when you divide by something, you invert and you, what's the answer? You invert and you multiply. Anytime you divide by something, you invert that something and multiply by it. So if this was b plus 5 over 1 as it is, then we just invert that and multiply by 1 over b plus 5. So this expression now will become as follows, okay? It will become b squared plus 6b plus 5, okay, divided by 6 times 6b plus 6, and we're going to now change this to multiplication, okay, and we're going to multiply by 1 over b plus 5. One over b plus 5, like this. Now the next step is to simply factor everything and see what you can cancel. So factor and see what you can cancel. And hopefully you can notice here that so let's go ahead and factor the left side of this numerator. What are the factors of 5? 1 and 5. What's 1 plus 5? 6. So this is pretty easy to factor. It's straightforward. Should not present any problem to you. So this becomes as follows. B times b gives b squared. 1 times 5 gives 5. And everything's plus, so this is plus. And this is also plus. And in the bottom, we can factor out the 6. So this is 6. Six times b plus 1. And then this is multiplied by 1 over b plus 5. So notice what happens here now. And if you like, you can think of this as having parentheses around it, because what's above it is a grouping symbol. So it is divided into b plus 5 above on the left. So we can cancel these. This cancels, and b plus 1 cancels. So what's left? 1 over 6. Okay, very good. 1 over 6. So this is just equal to 1 over 6. What an exciting problem. There you go, simplified. Let's move to example number 4. Example number 4. So in example number 4, I hope you realize right away that this thing over here is, this is the difference of two squares. And so is this, difference of two squares. So they factor very nicely. 1 is 1 squared. 49 is 7 squared. So we can rewrite this as follows. Y squared get my colors right. You can rewrite it as y squared minus 1 squared over y squared minus 7 squared times y minus 7 over y plus 1. Okay? And this will now reduce down nicely because this will factor. We have y plus 1 times y minus 1 times y minus 7, all divided by y plus 7 times y minus 7 times y plus 1. Okay? And now we look and we say, what can we cancel? What can we cancel? Well, the y plus 1s cancel. The y minus 7s cancel. And we're left with y minus 1 over y plus 7. Y minus 1 over y plus 7. Okay? Y minus 1 over y plus 7. That's our simplified result right there. Pretty straightforward, not too hard. Okay, let's go on down now and find example number 5. Example number 5. Okay, example number 5 is this one, r plus 2 over r plus 1 divided by 4 over r squared plus 3r plus 2. Now, you notice what we're dividing by? We're dividing by a fraction. What's the rule? When you divide by a fraction, what do? Okay, we're thinking simple fractions here. When you divide by a fraction, you invert and you multiply. We do the very same thing here. So this will become as follows. R plus 2 over r plus 1 times r squared plus 3r plus 2 all divided by 4. Okay. Now, just as we do when we deal with just simple fractions of just plain old numbers, we need to factor them in order to find out what we can cancel. I showed you this in my last video. I think we used, if I remember right, the fraction was like 12 over 18 or something like that. Okay, you factor it, then you look for the common factors and you cancel them. So here we do the very same thing. We need to factor this trinomial up there on the upper left. So this becomes r plus 2 over r plus 1 times, now we look for factors of that, and this is all over 4. R and R makes r squared. 1 and 2 makes 2, and it's plus and plus because everything's positive up there. Notice that 1 plus 2 equals 3. So this works out nicely. And if it makes you feel better, we'll put parentheses here, okay? You don't really need them, but you can put them, all right? So let's go ahead now and cancel what we can cancel. You see the r plus 1? Those cancel out, all right? R plus 1's cancel. And we're left with r plus 2 times r plus 2 all over 4. What's r plus 2 times r plus 2? Well, I hope you would say that's r plus 2 quantity squared all over 4. There's your answer. Simplified. R plus 2 quantity squared all over 4. So I think that about wraps it up here for this particular section, 11-4. It's pretty straightforward. I'm going to go ahead and do another video for you right on the heels of this one, 11-5, because I think these concepts are really not new to you. You've seen things like this in the past. Maybe not quite to the same level, but I mean, canceling fractions, reducing fractions, I think is something that we've done a little bit of already, and you know, a little bit more of it is probably not that big of a surprise to you. So we'll call it quits right there for this section, and we'll go ahead and put up another one right on the heels of this.